Hello, welcome to Arctics, the revolutionary NFT marketplace. An NFT, non-fungible token, is a unique identifier that represents ownership or proof of authenticity of a specific digital or physical asset. An NFT marketplace is a secure online platform that enables individuals to engage in trading activities, including buying, selling, renting, and lending NFTs, leveraging the immutability and transparency provided by blockchain technology. John, who is a professional gamer, owns an NFT which provides a superior weapon in Game X. Alex, who is another more infrequent gamer, plays Game X but doesn't want to spend $500 to buy the weapon NFT. Solution: can Alex rent the NFT from John when required by paying a daily rental charge? So when looked at the benefits, John can receive an passive income when he is not playing. Alex can use the weapon without spending a large sum at once. Alex can rent only when needed, if he is not a frequent gamer. Being a highly beneficial trade, let's see how rentals can be developed. ERC 721-based NFTs only have an owner. Hence, when a rental is required, the lender was needed to transfer the ownership to the renter via a blockchain transaction. After the period of rental, renter was required to transfer the ownership back to the lender via another blockchain transaction. Such an approach brings few issues. After the period expires, will the renter return the ownership? Can ask for a collateral from the renter at the beginning. This will require more blockchain transactions, and it is not very convenient. Also, a traditional rental agreement required 2 blockchain transactions, as explained earlier. Our rental mechanism uses a novel way which doesn't require a collateral. It was built based on the ERC 4907 standard, which adds a user role to NFTs. Further, a variable which can hold a timestamp was included in each NFT. Using the newly defined user role and the timestamp data, renting can be achieved in a single blockchain transaction. Via the transaction, the user role is updated to the identifier of the renter. Timestamp is set to the future time where the rental agreement ends. Automatic expiration of the rental is achieved by exposing the user role in a controlled manner. If the timestamp is in the future, the identifier saved in the user role is recognized. And if the timestamp is in the past, the identifier saved in the owner role is recognized. Let's discuss the design aspects and different components that brings Arctics to life. Arctics Marketplace consists of 6 major components. Front end provides the user interface where users can interact with the trading functionalities. Front end uses the MetaMask wallet to sign user transactions and IPFS to store metadata when creating NFTs. Trading requests are initiated from the front end and are sent to the proxy layer of the marketplace. Proxy layer consists of 3 Solidity written smart contracts deployed in the Avalanche Fuji network. The corresponding proxy layer contract, after receiving the request, loads the functionality from the implementation layer and executes. The state change occurred due to the transaction is broadcasted within the blockchain via custom-defined events. These events are captured by the back-end server, which listens to the events occurring in the blockchain via WebSockets. Server logs all the events captured into a MongoDB database, and are used to provide a seamless user experience to the users. Wrapper contracts are also written in Solidity and are used to upgrade existing NFTs to the ERC 4907 standard. Rule Engine is in charge of upgrading the functionalities defined in the implementation level contracts. Proxy architecture. Let's consider a request to list an NFT for selling from the front end. The request is sent to the Proxy Smart Contract, PC1, which handles sell listings. As PC1 is in the proxy layer, it doesn't know the actual behavior for listing an NFT. Hence, PC1 routes the original request to the implementation layer contract, IC1, which knows how to handle a sell list request. This is facilitated by the low-level call, delegate call, provided in Solidity. Now IC1 executes the behavior for the listing and acknowledges PC1 with the result, then PC1 emits the corresponding event acknowledging the back-end server that the listing is completed. The important thing to note is that, even though the request gets executed in IC1, the storage which gets modified by the execution is of PC1. This design effectively decouples the state and the behavior of the marketplace. Hence, IC1 can be replaced with IC2 at any time without any effect to the marketplace state. Event Listener. The proxy layer of the marketplace is responsible for emitting events to properly acknowledge the state changes of the marketplace. As the proxy layer consists of 3 smart contracts, the backend listens to all the events coming from those smart contracts. There are 2 methods to capture events broadcasted in a blockchain. Run a node in the blockchain and receive all the events in the network. Connect to the blockchain WebSocket, receive events emitted by any given smart contract. As concern is only to listen to the proxy contracts, Avalanche WebSocket connections were used in the development of the event listener. The capture of any event at the backend server initiates the database writer to log the information carried by the even-in to the MongoDB database. Wrapper. As explained earlier, ERC-721 NFTs are inherently harder to rent. But ERC-4907 NFTs provide a convenient set of functionalities to support renting. ERC-721 owners can use the wrapper mechanism to upgrade any existing ERC-721 NFT to ERC-4907 standard. First owner must create a wrapper collection, WC, to the collection that relevant NFT belongs to. Then he needs to deposit NFT to the wrapper collection, WC. A successful deposition creates a new ERC-4907 NFT which wraps around R721 NFT. The ownership of N1 will now be automatically transferred to WC. At any point of time, Jack can withdraw ERC-4907 NFT from wrapped collection, terminating the existence of ERC-4907 NFT. As any other web application, Arctics may face erroneous conditions in the behavior and would require to fix such conditions. Similarly, from region to region, compliance and regulatory conditions can differ, requiring behavior changes. Due to the implementation of the proxy architecture, behavior upgrades become highly convenient. Owner just needs to swap the current implementation contract with the upgraded contract. The rule engine realizes this functionality. Rule engine allows authorized users to inspect existing functionalities and modify them using an intuitive user interface. Once the user is satisfied with the new functionality, the rule engine parses the new functionality and creates a Solidity file. Once the Solidity file is completed, the rule engine automatically compiles the contract and deploys it into the blockchain. Now the owner has to manually update the pointer of the corresponding proxy contract from the older implementation contract to the new one. As it is not ethical for the owner to directly do this transfer, the rule engine imposes a voting mechanism. There are a set of predefined voters, and if and only if all the voters have agreed for the upgrade, the owner can initiate the pointer update. This way, a secure and seamless behavior upgrading mechanism is achieved. To evaluate the behavior of the marketplace, it was deployed in both Avalanche Fuji Testnet and the Ethereum Gurley test network. A fixed set of trading activities were conducted on both the platforms, and the findings can be observed as follows. Gas comparison, performance comparison. Apart from the performance comparisons, all the marketplace behaviors were thoroughly tested using Truffle Sweet Mocha. Let's go through a quick demo.